Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Stability of resonance, canonical, structures depends on factors such as charge placement on electronegative versus electropositive atoms, completeness of octets, and aromaticity or extended conjugation. Moving on to the next step. Analyze structure I. Structure I has a carbocation, positive charge, on a carbon atom that is not adjacent to the oxygen lone pairs in a stabilizing way. The positive charge is on a saturated carbon with no direct resonance stabilization from oxygen. This is the least stable structure. Moving on to the next step. Analyze structure 2. Structure 2 is an oxocarbenium ion where the positive charge is delocalized between carbon and oxygen, C is equal to C with O nearby. This provides partial stabilization because oxygen's lone pairs can donate into the adjacent carbocation, but the charge is still on carbon rather than on oxygen directly. And for the final step, analyze structure 3. Structure 3 shows the positive charge placed directly on the oxygen atom, and the ring has two double bonds at C2, C3 and C4, C5 positions, forming the beryllium-type cation. This structure resembles the beryllium cation with extensive conjugation throughout the ring. Although oxygen bears the positive charge, oxygen has lone pairs and can accommodate a positive charge better than a simple carbocation when the resulting structure is fully conjugated. More importantly, this structure has maximum delocalization of the pi electrons across the entire ring, 4 pi electrons from two double bonds plus the empty orbital charge, and the positive charge on oxygen is stabilized by the electronegativity considerations and the full conjugation of the system. In terms of resonance contributor stability among these three, structure 3 places the charge on oxygen which is more electronegative, but the extended conjugation and the fact that oxygen can bear positive charge through lone pair donation makes this the most contributing stable resonance form. The fully conjugated system, beryllium-like, with delocalized positive charge across the ring is the most stable canonical structure. Why other options fail? Structure I, carbocation on a carbon with no adjacent pi system or heteroatom stabilization, least stable. Structure 2, partial conjugation and carbocation partially stabilized by oxygen, intermediate stability. Structure 3, maximum conjugation, charge on oxygen with full pi delocalization across all ring atoms, most stable. Option D is incorrect because the structures differ significantly in stability. Therefore, the correct answer is C. Therefore, the correct answer is option C.